Okay, so when you're graphing quadratic inequalities, we're going to start very similar to the way we did when graphing parabolas. And when it says like graphing it in two variables, that just means with x and y. And then we're going to solve them using algebra. Okay, so the one thing that's going to be different is we have to pay attention to the signs. So when you're graphing your inequalities, it's either going to be a greater than sign or a less than sign. And if there's no equal to, your parabola is going to be dashed. Okay, it's going to be dashed because that means it does not include those values. And then if it is greater than equal to or less than equal to, that is when you will have a solid line. Okay, so dash or solid based on your sign. Bless you. Okay, so when you are graphing quadratic inequalities, you are going to have to shade. Bless you. And that's because there's multiple answers. So when you just have something like x equals 3, okay, there's only one answer. But if you have x is greater than 3, there's a bunch of numbers that are greater than 3. So we have to make sure we shade in all of those solutions. So the solutions for inequalities contain many solutions. Okay, so therefore, in addition to graphing the curve, we need to shade regions. We need to shade regions to represent all those possible solutions. Now we are going to use test points. You guys may have remembered that we did this earlier this year. You guys remember our most common test point that we used? Yeah, good. Okay, so we're going to determine that. We're going to use that to determine if you shade inside the parabola or outside the parabola. Okay, so inside the parabola or outside the parabola. Okay, so for example 1, we are going to graph each inequality. So when you are creating the table, the first thing we're going to do to find the vertex is the opposite of b over 2a. And you always want to do that part first. So your b value is -7. So if I do the opposite over 2 times a, I get 7 over 2. So I'm going to put that in the middle. This is going to be your vertex. Okay, and 7 over 2 is the same thing as 3.5. So sometimes when we have a decimal, that gets a little bit confusing of where to go next. You really could do like 4.5 and 5.5, but it is easier to do whole numbers. So if you go 1/2 up to 4, you would just go 1/2 down to 3. If you went up to 5, 5 is 1.5 units away from 3.5. So if you subtracted 1.5, you'd get 2. So you're still going to have symmetry there. Okay, now when you're creating a table, I want at least 5 points on there, but you can use more than that to help you create the graph because we want to span the grid. Okay, so we're going to go to our y equals, and we're going to plug in that quadratic expression, x squared minus 7x plus 10. Okay, and you can look at the graph, that's fine, but really what we want to use is the table feature. Okay, they're always going to show you that with the solid line when you're graphing because it's not the inequality there. So if you go to your table, a lot of your tables will start at 0. Okay, you can find the 4 and the 5. So you have -2 and 0. And then you can see at 3 you have -2 and 0. Those should be symmetric. Okay, to find out what happens here, there's a few different ways you can do it. So if x is 3.5, what's one way you could find y? Yeah, you just plug it into the equation. You can plug 3.5 into the equation. You can also use your table set feature. You can put your table start at 3.5, and you can see that it's negative 2.25 that way. That would be fine. Okay, and then you could change your table back. So if you wanted your whole numbers, you could still have that. How else could you find your vertex? Could you find it on your graph? Yeah, what's the feature that we use to find that? You can do the minimum. You could do the left bound and then the right bound, and you could find your y coordinate that way. I do want you to use the opposite of b over 2a, because you can see that that's exactly 7 over 2, and then this one, it's rounded a little bit, okay, but it does give you your exact y value. Okay, so there's several different ways that you can find that. Okay. All right, so we're going to create a grid here. And so when you're creating your grid, like I have 2, 3, 4, 5, so I don't really need to go into the negatives too far. And I have negative 2.25, so maybe I want to go to like negative 3, negative 2, negative 1, 0, like this. Right, because you guys are going to be spanning this on craft paper. So I know a lot of times you just do like the 10 by 10, but you don't have to. You can make it fit what you have here. Okay, so this is 2, 4, 6, 8, if I'm going by ones. Alright, and then we're going to plot our points. So I have 2, 0. I have 5, 0. I have 4, negative 2. I have 3, negative 2. Okay, and then at 3.5, I'm at negative 2.25, so about right here. Now, whenever you are doing this, you want to make sure that you are spanning your grid. Okay, so if we're going to span the grid that we've created, then let's use our table to make sure that we have everything, because we don't want to just stop it here. Okay, so at 6, I'm at 4. Okay, which means at 1, I'm also at 4. Okay, and you don't have to put your axis of symmetry. At 7, I'm at 10. So that would be like up here, so just know like where you're going towards. And then, is this going to be solid or dashed? Why? Yeah, because it's the equal to. Okay, so it's going to be solid because this is your symbol. You have the equal to, and then I like to do this with a pencil because sometimes I forget to do my dashes, so we're going to span the grid. Remember, this is going up towards your 10. Let's span the grid here. Okay, and then the last step, this is going to be something that you're required to do, is use a test point. Okay, so these are your 3 steps that you're going to have to do on your homework. Okay, and then like you guys told me earlier, we often use 0, 0. You can always use 0, 0 if it is not a point on the parabola. And your test point, you were going to plug into your original equation. So your original equation is y is greater than or equal to x squared minus 7x plus 10. If you plug in 0, you're going to get an inequality, and you just have to say whether it's true or false. So can you guys simplify that and then tell me if it's true or false? Yep, and write it on your paper for me. And then we're going to assess what we have to shade. So what region we have to shade in. Okay, so you have 0 is greater than or equal to 10. Is 0 bigger than 10? No. Okay, so then I want you to write out whether it's true or false. You can put the slash through here. Okay, so I need to see this part. Okay, so you'll have a table, you'll have your graph, you'll have whether it's true or false. Okay, and then I want you to have this part in your notes. So if it is false, what that means is you do not shade 0, 0. Okay, so we just have to look at the position of 0, 0 on the graph. So if 0, 0 is outside, that means we are going to shade inside the parabola. Now that doesn't mean that if it's false, you're always shading inside. That's not true. It depends on where your position is. Okay, so because 0, 0 is outside and it's false, we can't include that in our solution. So we shade in the opposite region. Okay, so we're going to shade everything inside the parabola. Okay, and then once you have that shaded, you can go ahead and do step 1 on part B. So create your table for part B. Okay, so we always want to find that vertex first. So 6 divided by -6 is -1, and that tells you where your vertex is. Okay, so that just goes right in the middle. That's your vertex. So if you have -1, you can find out what happens at 0 and 1, -2 and -3. Okay, and again, this is something you can use your graphing calculator to help you with. Create the table. You'll know that you found the correct value if you can see the points are symmetric. So here we get -4, and then at 0 we have -7, at -2 we have -7. Okay, so you know that you've done that right. Okay, and then we can see after that is to -31. Okay, that's kind of a lot, so all we're going to need are those points. So if I'm trying to go to -16, okay, I'm probably going to want to go by 2's, and then I have most of my points that are in the negative range here. So when I'm making my graph, I'm keeping that in mind, right? I don't need a bunch of points in the positive. And then I can go by 2. So this would be 2, -2, -4, -6, -8, -10, 12, 14, -16. Okay, so my y's I can scale by 2's. My x's, I don't need to scale those by 2's. I can still go by 1's there. Okay, so your x values have to be the same distance apart, your y values have to be the same distance apart, but your x and y's don't have to be the same scale. All right, so then at -1, I am at 4. So 2, 4. At 0, I'm at -7. So 2, 4, 6, 8. So this would be 7. That's you. Okay, and then at -3, I'm at 16. And at 1, same thing. Now, is this a solid line or a dashed line? Do we remember? Okay, I forgot earlier. So if you used a pen and you forgot to make it dashed, you can use a highlighter and just go over it. Okay, and then with your dash, it's still going to be in the shape of a parabola. Okay, and then we still need to see that equation. Okay, so you can use 0, 0 as your test point. Okay, and then when you're plugging in 0, 0, it's okay if you have 0 plugged in for y. What's going to happen with these? If you follow your order of operations here, you're just going to be left with what on this side? Yeah, -7. So you have 0 is greater than -7. Okay, is 0 bigger than -7? What's bigger, 0 or negative? 0. Okay, so this is true. So you can put like a little check if you want, true. Okay, I want an acknowledgement of whether it's true or false, and I need to see this expression. Okay? And then I do want this note down here for your notes so you understand where you're shading, why you're shading there. So if it's true, you're going to shade the point 0, 0. So your point 0, 0 is outside. Okay? So you're going to shade outside the parabola. Okay, so if it's true, you want to shade in the point 0, 0. Sometimes I just shade around the parabola first to make sure I don't get too crazy and shade anything inside there. Okay, and then one of the reasons why it is important that you span the grid is sometimes I have people who were like, they have the parabola and then they were shading outside and then they were shading all around here. That is incorrect because this keeps going, right? If this parabola keeps going, this should not be shaded underneath, okay? But, oh, thanks. It's everything that's on the outside there. Okay, so if this is your parabola, right? If you didn't span the whole grid, some people were trying to shade underneath and you can't do that. Okay, so you want to make sure you span your whole grid. It's like an umbrella, right? The rain's all on the outside of that. All right, so that is how you can solve by graphing. If you're ever unsure if you shaded the right place, anything you shaded should make this equation true. So you can pick any point in the shaded region, plug in the x and the y, and it should be a true statement. Or you can plug in any point here that's not shaded, and that should be false. So all of your solutions are in the shaded region. Okay? All right, now we're also going to learn how to solve these using algebra. Okay, so when you're solving quadratic inequalities using algebra, I've written out a series of steps for you to follow. So the first thing you're going to do is you're going to move all terms to one side. And sometimes that's already done for you. And then you are going to factor. After you factor, you're going to find what's called the critical values. This is where each factor equals 0. And then we have to express those as inequalities. We're going to do that on the number line. And we're going to do this together. We'll go through the steps together. After you do that, we are going to make a table. And on this table, we're going to have test points. And we have to determine if they're true or false. Okay, so we're going to pick test points and determine if they're true or false. And then your solution is going to be the intervals where the test points are true. So your solution is either the interval or intervals. Sometimes there's one, sometimes there's more than one, where they are true. Okay, so when you're doing your homework, this is going to be in the mixed exercises section. And so that's why I called this mixed exercises. So you're going to solve each, this is the directions the book has. It says solve each quadratic inequality by using a graph, a table, or algebraically. Okay, we are going to do this algebraically. All right, so that is going to be your choice for these. You'll have other ones where you're solving using the graph. Okay, so this is how you're going to be required to solve on your homework and on your quiz. Okay, so on your quiz, there'll be some that have the graph. There'll be other ones that are going to be solved with algebra. All right, and then we're going to use our checklist to help us with this. So the first thing is move all the terms to one side. Well, that was already done for us. You know they're all moved to one side if you have 0 on the other side. Then we're going to factor. Step 2. We're going to keep the less than 0. Okay, so when you factor, if it's x squared, you can start with x and x. You're looking for two numbers that multiply to -2, but add to, what do I have to add to? -1. Okay, so you should have -2 and +1. And then, of course, you can always guess and check to make sure that -2x and 1x is going to be -x, which it will be. Okay, then we're going to find the critical values. The critical values are just what makes each of these 0. So if you have x minus 2, okay, you can set that equal to 0 and solve. What could you plug in for x that would make this true? Yep, +2. So this is a critical value. The other one is x plus 1. Okay, so if you subtracted, then you'd have x equals -1. That's the other critical value. -1 would make this 0, 2 would make this 0. Okay, and then what we're going to do is we have to find the intervals that are created by these critical values. So the easiest way for me to explain that to you is with a number line. So on the number line, we're going to put our critical values. Okay, so on a number line, you have to put these in the right order. -1 goes first and 2 goes second. Okay, so this splits the number line into 1, 2, 3 parts. The first part is here. These are all the values that are less than -1. Okay, so these are all the values where x is less than -1. Okay, you're used to graphing these separately, so really what you're trying to do is you're trying to say, okay, if this was -1, what would my equation be if I had -1 all the way to -infinity? So it would just be x is less than -1. Do you guys think you could do this one on this end? What would this end be? X is greater than 2. Okay, and then the last one is the middle one. So in the middle is just your in between these two values. So it's just -1 is less than x, which is less than 2. Okay, so you are setting up those intervals. The critical values are going to separate the number line into 3 intervals. Okay, and we're only doing the ones where you'll have 3. So we're going to take those intervals and we're going to write them in this lovely table. So our intervals are x is less than -1, x is in between -1 and 2, and x is greater than 2. So you have 3 intervals created by those 2 critical values. Okay, now we have the less than signs here and the greater than sign because of this. See how there's no equal to here? Okay, if there's no equal to, then that's what you're going to include in your intervals. If there isn't equal to, we will include it. Okay, now when you're choosing your test point has to be a number in the interval that's not a critical value. So we're going to pick a number in the interval that is not a critical value. Pick a number in the interval that is not a critical value. Okay, and you really wouldn't do that for this anyway. You have x is less than -1, so you wouldn't pick -1. But what is a value that's less than -1? -2 is probably the most common thing you guys will use. You can use anything that's less than -1. Okay, what's a good number that's between -1 and 2? You could use 1, you could use 0. Either one of those are fine. I like to use 0 because it's just simpler to calculate in your head. And then a number greater than 2, 3. Great. Okay, so your test points, you are just testing, you are just checking to see which one of these satisfies the equation. So it's your original equation here, your x squared minus x minus 2 is less than 0. Okay, and all I need to see is like your final inequality, but I'm going to show you how you plug this in. You can use some mental math strategies for this. You have to follow your order of operations. So -2 squared would be 4. Negative times -2 is what? +2 minus 2. So this is going to simplify to what? Is 4, right? 2 minus 2, 0, so 4 is less than 0. Is that true or false? False. Okay, so we're going to cross that out. We're going to put an F for false. All right, and then let's plug in 0 for this one. If you plug in 0, you have 0 squared minus 0 minus 2. What does that simplify to? 0 minus 0 minus 2. -2. Okay, and then again, you just ask yourself if it's true or false. So the sign's always eating the bigger value. Is 0 bigger than -2? Yep, so then your answer here is true. Okay, and then again, this is what I'm looking for, is that final equation there. And then we're going to plug in 3. Okay, so 3 squared is 9. Would be minus 5. 9 minus 5 is 4. And then we actually have the same inequality that we had above, so we know it's false. Okay, so we're trying to find the solutions that make this true. So because this interval gave us a true statement, okay, your final answer is just a negative 1 is less than x, which is less than 2. Okay, which means all of these values in between here are going to make that a true statement. All right, so I want you guys to start part B. So I want you to do steps 1 through 3, and then I'm going to show you how to write this out. You don't have to write the table in your notes every time. But I want you guys to move everything to one side and then factor, and then find your 2 critical values. Okay, so when you're starting your factoring, we know it's 2x and x. It's going to multiply to 2x squared. This is pretty nice because the only thing that multiplies to negative 1 is what? 1 and negative 1. So I just have to figure out which one is positive, which one is negative. If you want to add to a positive, the 2 is going to have to be positive. So you need a plus 1 here, a minus 1 here. Again, that's something you can always check with FOIL. You have negative 1x and 2x, which is just going to be x. Okay, so that is the correct factorization. And then for your critical values, okay, we just need to set each one of these equal to 0 and solve. So your critical values are always what would you plug in to make this 0. So if you added 1 to both sides and then divided by 2, you'd have x is 1/2. That's one of your critical values. The other critical value is negative 1. Okay, so I gave you a nice chart for that first one, but I don't expect you to draw that chart out every time. So I'm going to show you a way you can turn your number line into a chart. Okay, so we're gonna set up the intervals here. Okay, on a very large number line. So you make your number line with me. And again, these have to go in numerical order. So you have the negative 1 that goes first, and then the 1/2. Now when you're setting up the intervals, again, you're going to just look at this sign. So there is an equal to. If there is an equal to, then this part of the interval is always x is less than. So this is less than equal to. Okay, so this part of the interval is x is less than or equal to negative 1. This part of the interval is always greater than or greater than equal to. Okay, because it's going to positive infinity. And the one that's in the middle has x in the middle in between your 2 values. Okay, so it splits this up into 3 pieces. Okay, so what you're going to do is you're just going to make this into your chart. So you're going to identify what your test points are here. Just going to call it TP for test point. So what would be a good test point for this interval? X is less than or equal to -1. -2, great. Okay, between -1 and 1/2, 0. Above 1/2, 1. Okay, and then when you are plugging these in, you're just going to plug them in. You can either plug them into the original or what you got in step 1. So you have 2 -1, or sorry, this is -2 you're plugging in. So 2 -2 squared minus 2 minus 1 is greater than or equal to 0. Okay, the main thing I'm looking for here is that final value, and make sure you do your order of operations. So -2 squared is 4. 4 times 2 is 8. So you have 8 minus 3, which is going to be 5. So is 5 greater than or equal to 0? Yes, so that's going to be true. That means part of your answer has to be this interval. Okay? All right, and then we're going to plug in 0. So you have 2, 0 squared plus 0 minus 1 is greater than or equal to 0. Okay, anytime you plug in 0, you're left with that y-intercept. -1 is greater than or equal to 0. Is -1 bigger than 0? No, so it's false. Okay, so we're not going to include that. And then we also have to check this one. So you have 2, 1 squared plus 1 minus 1. Every time I plug that in, I'm just looking at my first step here. Okay, so I'm plugging in 1 every place there's an x. I can see here this is going to cancel out, right? And 1 squared times 2 is just 2. So is 2 greater than or equal to 0? Yes. So if you look at these inequalities, both of these are solutions, but you can't have a number that's less than or equal to -1 and greater than or equal to 1/2 at the same time. So do you guys remember what we connect them with? An or. So x is less than or equal to -1 or x is greater than or equal to 1/2. All right, and then today is the start of the new quarter, so you want to start that new quarter with some 100% homework scores. I'm going to give you time to do that today. You have less than 10 problems.